Yeah, a properly normalized database should have the following characteristics. So it will have scalar values in each of the fields and absence, or it will have minimum redundancy and minimal use of null values and minimal loss of information. So these are the characteristics of a properly normalized table or a relational database design. Now we have seen that when we go for normalization, we are actually the down arrow, that is the redundancy is coming down, and the number of tables in the design will go high, and the complexity will also go high. All right. So when you normalize, the primary focus is to remove the redundancy or to minimize the redundancy at the cost of higher number of tables and higher level of complexity. Levels of normalization is based on the amount of redundancy in the database. So we have seen that we have 1NF, 2NF, 3NF, BCNF, 4NF, 5NF, and there is a recent normal form which is called DKNF, domain key normal form. So one observation is that most of the databases should be either in 3NF or in BCNF in order to avoid the database anomalies. So once you normalize a table or once you normalize a database designed either to the third normal form or BCNF, people will in general say it is good enough. Going to 4NF and 5NF, etc., may not be required in most of the cases. As because of these two arrows, you can see that the number of tables will go high and also the complexity will increase when you go beyond PCN. So more or less people are satisfied with the database design if you can normalize it up to either 3NF or a PCN, right? So this is another view of the thing. 1NF, 2NF, 3NF, 4NF, 5NF, and DKNF. So this conveys an important point that all relations which are or all tables which are in fifth normal form are automatically in fourth normal form. And all relations which are in fourth normal form are automatically or by default satisfying the conditions of third normal. So this is in a circular manner or one within the other. So once you say that a database design is in 5NF, it satisfies all the conditions of being in 4NF, 3NF, 2NF, and 1NF, not vice versa. That means a relation which is in 3NF may not be satisfying the condition of being in 4NF. But a 4NF relation definitely satisfies the condition for being in a the third normal. It is very important. So please note that a relation which is in DKNF, domain key normal form, satisfies the condition for being in fifth normal form also. So this is a point which we have to note. So we have seen regarding first normal form in the last class. So here the condition is that a table is considered to be in N if all the fields contain only scalar values or atomic value. In other words, a list of values are not allowed for any of the fields. So the example given here, you find that it is all about books and there are authors for the book, and there are author fonts. And here you can find that there can be multiple authors for a book, and there can be multiple fonts, mobile phones or contact numbers for the authors. So both are violating the condition for this relation to be in one and. So this is actually a table which is not in the first normal form because of multiple authors as well as multiple other forms. How this can be normalized into first normal form? Devendra Yadav. Suppose I want to make it into first normal form. What should I do?
Sir, we make the entry for every repeated attribute in the, for example, we take the first attribute. We will make the entry for a Sleepy and the Snoopy and the Gumi for the, so that they don't have a multi-valued attribute.
That is what has been done, Devendra.
Yes, sir.
That is what is done at present.
No, sir. I'm saying that we will make a separate entry for every attribute or attribute value. We will make a separate entry, sir.
Okay.
So that.
So you mean a separate row?
Yes,
So,
sir. Yes, sir.
so you have ISBN number, balloon, sleepy, and the corresponding other phone, and then the rest of the value. Then you have again ISBN number repeated in another row, balloon, Snoopy, with the corresponding mobile number and other columns, other elements repeated. Again, the ISBN number, balloon, ground P, the corresponding mobile number and line. So the way to normalize this is by going for a separate row for each of these values. Okay, I think that is what Devendra also said. He was saying that separate entries means separate rows, or in the relational context, they are called tuples. So we have a separate tuple for each of those other names as well as for the mobile. All right. Now, the thing you might have already noticed that when we are going for multiple rows, we are actually having more redundancy or less redundancy in the table. Abhinav, when you go for separate rows, are we having less redundancy or more redundancy?
So individual tables will have less redundancy, but when we combine, then redundancy will be more.
No, when we are normalizing it in the first normal form, here in the earlier example, are we reducing redundancy or are we increasing redundancy?
Reducing, sir.
How?
So because we are creating different tables and each table is having unique entries, sir.
No, here we are not creating different tables, actually different rows in the same table. So we have the ISBN number, title, and publisher name, publisher phone, and price repeated for every author name and every author phone. So actually, you are increasing redundancy here. The example shown here, when you go for separate rows, the redundancy increases. All right. Okay, please note that point, Abhinav. All right. So here, first normal. So here you have decomposed the table. So you have, I mean, you have placed all the items that appear in the repeating group. There is another way by decomposing the table into two. You have title, publisher name, publisher phone, and price coming in on table, and author name, author phone as a separate table. So in that way, you are reducing. In the solution suggested earlier by Devendra, there what he has suggested is a separate row for each author. So here what has been done is you have title, publisher name, publisher phone, and price coming as a table, and you have author name and author phone coming as another table. So author name and author phone are the repeating groups, but here we put them in a separate table. So is there any redundancy here in the first table and in the second table? Give your comments on that. Yukta, can you comment on the level of redundancy present in these two tables? Yukta?
Yes, sir.
Yeah, can you comment on the redundancy present on these two tables? Is there any redundancy present?
Uh, I think no, sir.
Yeah, but if you look into the second table, you can see
But
that
same primary key is present many times.
no, it is not the primary key here.
Table.
No. What is the key in the second table?
Actually, ISBN is unique. ISBN value.
Good. Yeah, but the ISBN number is not unique in this table. It is
Yes,
coming in 3 rows.
Yes, sir. I think that is the reason.
So what is the key of this table? Ajwad, what is the key of the second table?
I think it is author phone number.
Author phone number. Combined. Combinedly or
Combined
other,
author phone number and author
other phone number? Okay, assuming that every author has a separate phone
separate.
number, we
Yes.
can say that, and if we assume that an author may not be an author for many books, then we can say that author name, author phone is the key, isn't it?
Yes, yes.
Because say the author Smith might have written more than one book. So what will happen is his phone number will be repeating. Author name and author phone will be repeating with every book that he is writing. So we cannot say that an author will write only one book. Okay, probably the assumption that the author has got only one mobile number or author phone can be accepted. But if the author is allowed to write any number of books, then it cannot be the key. So what will be the key in that case?
ISBN and the author name.
Yeah.
ISBN and the author name combined.
Okay. ISBN and author name put together can be the key provided. But if the author is writing multiple books corresponding, then there cannot be
ISBN
that also won't be true.
ISBN will be different. If the author is writing
ISBN and yeah, if ISBN and author names, but you have okay, yeah. So yeah, that is correct. That means if you assume that the authors are going to have only one phone number, but they are allowed to write multiple books, so the ISBN number plus author name can be the key. All right. But if the other phone is also not unique, or the other can have multiple phones, or the phone can be shared by multiple others, then what will be the key for this table? Anaka?
Hello, sir.
Yeah.
Sir, we
Other?
can
Yes.
ISBN number and author name. We can combine and use it.
No, what I'm saying is, from the earlier example, I am just changing the meaning or the semantics of the data. That means author is allowed to write multiple books, and author can have multiple fonts, or the same font can be shared by multiple authors. If that is the situation, or that is the meaning for these different columns, by looking at the functional dependency or by looking at the semantics part, what can be the key here? Anaka? Anaka?
Hello, sir.
Yeah, what can be the key in such a context?
Sir, I am not getting it.
Okay, Arka Jodi? Arka Jodi? No response. Adhar? Adhar? Absent. Avinash Kumar?
Hello.
Yeah.
Yeah, yes, sir. So actually, sir, you're saying that author name could be repeated. Then you're asking the primary key, right?
Other name, I mean, other name could be repeated means one author can be, one can write multiple books.
Yeah. In that
Yeah.
case, the ISBN can be more than one, right? Means
Yes.
same
Yes.
ISBN can be more. So I think
Yeah.
in that case, we'll have to take all the three columns in the second one as the primary key.
All right. Yeah, that is the point. That means in this case, the entire tuple will be the key. ISBN number, author name followed by author font. That will be the key. Such tables are actually called all key relations. So the whole tuple will be the key in this particular case. In the first table, ISBN title, publisher name, publisher phone, and price. What is the key here?
Sir, in
ISBN number.
Okay, but with the assumption that yeah, ISBN number.
but if we are considering that the books are repeating, then in that case, I think we'll have to take ISBN and the publisher name and the title as the same.
Yeah, if multiple authors can be, or the title will be the same, publisher name. Yeah, I think in this case, look like the ISBN number can be the key, because here publisher, for every book there will be only one publisher, there will be only one title, and the publisher is having only one font. If you assume like that, there will be only one price. So ISBN number can be the key here. So here place all items that appear in the repeating loop in a new table. That is actually the solution. Designate a primary key for each of the new table produced. Duplicate in the new table the primary key of the table from which the repeating group was extracted, or vice versa. So you have to duplicate the new table, the primary key of the table from which the repeating group was extracted, or vice versa. Now going to the next level. Yeah, we have seen already about functional dependencies. So what exactly is the role of functional dependencies in normalization? Tarun, Zamira, Tarun. quickly, what is the
Hello,
role?
sir.
Yeah.
Yeah, using functional dependencies, we can find out in what normalization the table is in.
Yeah, but what is the role of functional dependencies? What is the role of, what is the importance of the concept of FD in normalization?
Using that, we can determine primary key or unique
The answer
tuple.
or the point that I would like to make is that I think there is somebody has given a chat message. Let me see what I do. I think, finding redundancy. Avinash is telling. Okay, different ISBN number. So here the point is that functional dependency is actually a mechanism by which you express the semantics of the data. So the meaning of the data, I was mentioning just now that an author can write multiple textbooks and multiple authors can have the same phone number, or the author can have multiple phone numbers, all, and there can be only one ISBN number for a textbook. All these things relate to the meaning of the columns or meaning of the table. I can write it in English, but it will be ambiguous. So anything that you write in a natural language can become ambiguous. So, however, whatever clarity you try to bring, there can be probably two interpretations of a English sentence. So, the formal way of expressing the semantics is by means of the concept of functional dependency. So, not the point that functional dependency, multi-value dependency are all formal notations or formal mechanisms by which we express the semantics of data in the context of a database design. All right. In one of, if one set of attributes in a table determines another set of attributes in the table, then the second set of attributes is said to be functionally dependent on the first set of attributes. So here some examples are given. So if you tell the ISBN number, you can tell the title. There cannot be multiple titles for a textbook with the same ISBN number. Similarly, there will be only one price for a textbook. So if I say the ISBN number, you can immediately say what is the price of that particular textbook. All right. Okay. Now more on functional dependencies. There are some more examples shown here. So here you can just see that, yeah, you have the first table where you have publisher ID, publisher name, and publisher font. And we have the functional dependencies from the publisher ID. We can find out the publisher font. From the publisher ID, we can find out the publisher name. All right. So publisher, from the publisher name and publisher font, you will be able to identify the publisher ID. So these are the three different functional dependencies in the first table. Similarly, look at the FTs in the second table or example 3. Just check the FDs and convince yourself that they are really the dependencies in the table of example 3. Okay, here we are assuming that every author will have only one phone number. So with that assumption, from the author ID, you can find out the author phone. From the author ID, you get the author name. And if you say the author name and author phone, you can find out the author ID. All right. Okay, now more about functional dependencies. Just read this description. So this is used for the coming slides. read the slide or read the case study carefully. So it is all about submitting, all about a technical conference where authors are submitting papers which are getting reviewed. All right. So you have different tables here. You have author information, which is including the author ID, author name, mailing address, and a unique email ID, which is said to be optional. Then for every submitted paper, you have an author, paper title will be there, paper number will be there, then you have the abstract and the review status. Whether it is accepted or rejected or it is under review, that is pending. Then reviewer information includes the reviewer number, name of the reviewer, the mailing address, and a unique email address, which is again optional. So a completed review includes the reviewer number, the date, the paper number, comments to the authors, comments to the program chairperson, and ratings, overall originality, correctness, style, and clarity of the paper. So this is actually the context which we are going to use, or this case study or this particular example we are going to use in the coming slides. So you have authors and you have papers and you have reviewers and you have reviews. Okay, authors are there and you have paper submissions are there. Then you have reviewer data and you have the review. So there are 4 different data items here. Yeah, look at the functional dependencies indicated here, and you may explain the meaning in English. So go through all the functional dependencies and please be ready to explain the meaning in English. Take 1 or 2 minutes to read the FDs. uh, Vishal,
Yes, sir. Yes, sir.
can you explain the meaning of the first functional dependency? Author number determines author name, author mail, and author address.
Sir, author number is the unique ID that we are, while registering, we are getting it, and through that we can successfully determine the author name, author email, and author address.
Now the question is, can an author, author can have multiple email IDs, multiple address.
Yes, an author can have multiple email address.
Okay, that is not mentioned there. Actually, the meaning is that if you tell the author number corresponding to every author number, the combination of author name, author email, and author ID will be unique. All right. Or if I say 5, the 3 elements associated with 5, that is the author name, author email ID, and author address will be the same always. There cannot be multiple combination of these. Similarly,
Hmm.
corresponding to every author email, there will be only one author number. All right. So if you say the author email, you can simply say the author. So this does it mean that, or what about the number of books that an author can write? In this case, if this is the functional dependency, Divyanshu.
Yes, sir.
Yeah, Divyanshu, according to the second FD, can an author write multiple books?
Yes, sir. An author can write multiple books. Yes, sir.
But will the functional dependency be the same?
Give me a second, sir.
Yeah, according to the FD given here,
Yes,
I
sir.
mean, the design does not allow the author to write multiple,
Okay.
cannot be author of multiple, because he's assuming that he has only one email ID. His email ID will come with many other numbers. All right.
Yes, sir.
So then it will not be allowed. So similarly, we have other functional dependencies. That is, if you give the paper number, which is the paper number corresponding to that, you have only one author, primary author number. You have the title of the paper, abstract and status. All right. So similarly, if you give the reviewer email ID, you put the reviewer number. These are the functional dependencies present in the table.
Yes,
All
sir.
right.
These functional dependencies are correct.
Yes.
Yes, sir. Yes, sir. This will hold, sir.
Yeah. Yes, Divyanshu. Now going ahead. So we are coming to the second normal form. So for a table to be in the second normal form, there are two different requirements to be satisfied. First is that the database should be in the first normal form, and all non-key attributes in the table must be functionally dependent on the entire primary. Okay. So all non-key attributes should be functionally dependent on the entire primary. Or this is, in other words, it is called full functional dependency. So all non-key attributes should be fully functionally dependent on the primary key. So that is the condition. These are the conditions for a relation to be in second normal form. All right. So what are the conditions for a relation to be in second normal form? First of all, it should be in first normal form, and all non-key attributes should be fully functionally dependent on the primary key. That means the non-key attribute should not be dependent on a partial subset of the primary. So the non-key attribute should be fully dependent on the primary key. It should not be dependent on a subset of the primary key alone. And not the point that this condition of full functional dependence is only for non-key attributes. Non-key attributes have to satisfy this condition. So why that is important, Sunita? Why that is important, that non-key attributes should be fully functionally dependent on the primary. Sunita?
Yes, sir.
What is the importance of that? Satya,
Yes, sir.
Satya, Lakshmi, Shetty, Patel. So
Yes,
what is
sir.
the importance of that? All only the non-key attributes should be fully functionally dependent.
Not sure, sir.
Yeah, Megha, Megha Ghosh.
Hello, yes, sir.
Yeah. So why we are stressing the point that remember that we are dealing with only non-key attributes.
Otherwise, it may suffer from the update anomalies.
Yeah. The point is that if there is an attribute which is actually part of some key, then it need not satisfy this particular condition. That is why it is repeated here. That means any field or any attribute which is part of a key need not satisfy the condition of full functional dependence. Now look at the table given below. So the table with the title of the book, publisher, title of the paper, publisher ID, author ID, price, and author address. So what is the key, whether it is in 2NF or not? Just go through it. Why it is not in second normal form? So here the key is title of the paper, publisher ID, and author ID. And if you say the title, publisher ID, and author ID, you can tell the price. But author ID determines the author address. So author ID does not belong to a key, all right, or the non-key attribute, author address, is dependent on author ID alone. So author address is not actually dependent on the title, publisher ID, and author ID put together, but it is dependent on author ID alone. So author address is functionally dependent on author ID, which is a subset of the key. So the condition of full functional dependency of all the non-key attributes on the primary key or on the key is not satisfied here. All right. So if you have an author, then address of the author is dependent on the author ID alone. Does not dependent on the title of the book that he writes or the publisher ID. All right. Because of these reasons, this table is not in. Switch off your camera. Switch off your mic. Sudhanshu. Okay, now you can see another example for second normal form. Here again, there are conditions. FDs are given and explanation is given why it is not in second normal. Basically, the condition of full functional dependency of the non-key attributes on the primary key is violated. Just convince yourself by reading the two different examples that they are not in 2NF. And if you have any questions, please ask.
Sir, what advantage are we getting from the restriction of all non-key attributes are fully functional dependent?
What? Can you repeat the question? What?
What advantage are we getting by putting the restriction of all non-key attributes should be fully functionally dependent?
Yeah, non-key attributes should be fully functionally dependent on the primary key. That will make sure that there is no redundancy. There is less redundancy. And when there is less redundancy, there will be less anomalies in the table. That means during insertion, deletion, etc., anomalies will be less. Okay. So here in the first example, the key is city, street, house number. So that city, street, house number determines house color, and the city determines the city population. So here condition is violated. That is, the city population is dependent on city alone, and the city population is functionally dependent on the city. Similarly, the house color is actually dependent on house color, house number. We can even say, okay, house color, that is not violating the thing, but the city population, the moment you say the city, you can tell the population of that city. So the full functional dependence of the non-key attributes on the primary key is not satisfied, and the first table is not in second. Similarly, the second table on studio, you have studio, movie, budget, studio, city. So the key is studio and movie, and you just see why it is not in second norm. So here the non-key attribute studio city is dependent on the studio alone, and it is not dependent on the studio and movie put together. Hence, this is actually not in second normal. All right. Now let us see another example. Okay. So what we do for arriving at second normal form from first normal form is by way of decomposing or dividing a table into smaller tables. So just read these points. I'm sure you might have studied all these things, but just we are revising how to arrive at second normal form from first normal. The different steps in that, how to convert a 1NF relation into 2NF. How do you arrive at the second normal? Please read. Okay, if a data item is fully functionally dependent on only a part of the primary key, move that data item and that part of the primary key into a new table. So if you have a partial dependency, plug them together and create a new table with that particular functional dependency. If the other data items are functionally dependent on the same part of the key, place them in a new table also. Make the partial primary key copied from the original table, the primary key for the new table. Place all items that appear in the repeating group in a new table. So here an example is given. Just go through that. It's all about full functional dependency of non-key attributes on the candidate key or the selected primary key. Okay. So second normal form, again you are going further. Here there is another example. So this is you have the key as studio and movie put together. So the underlying attributes are actually the key. And you have two non-key attributes, budget and studio city. And you can see that again there is a partial dependency, that is a city, studio city. Studio, once you give the studio name, you can find out the studio city. So this is also not in second normal form. And but if you decompose the table like this, that is movie, studio, budget. So the non-key attribute budget is dependent on this alone, and city is dependent on studio alone. So this new scheme, these two tables are actually in second normal. Similarly, here you find that the city population is dependent on city alone. So that has been separated into a subtable. So these two tables are actually also in second normal, whereas the first table is not in second normal. Now we move on to the third normal form. So the condition, what are the conditions for a relation to the third normal? So for a relation to the third normal form, there are two requirements: that the table should be in the second normal form and no attribute is transitively dependent on the primary. So when you say second normal form, it talks about full functional dependency, and third normal form is talking about transitive dependence, right? So the non-key attribute should be non-transitively dependent on the primary. Okay. So this form, third normal form, dictates that all non-key attributes of a table must be fully functionally dependent on the candidate key. That is, there can be no interdependencies among the non-key attributes. That means a transitive dependency is something which is very interesting. You have A determines B and B determines C. Hence, you have A determines C. So there A determines C is actually a transitive dependence. All right. So the non-key attribute should not be transitively dependent on primary. It should be a direct dependence. So that is what third normal form says. So third normal form has got two conditions: that all non-key attributes should be fully functionally dependent on the primary key. And second point is that this non-key attribute should be non-transitively or directly dependent on the primary. So the functional dependency should not be a derived on, or it should not be a transitive on. Okay? So just go through this particular example here, which is actually a table where you find that the table is not in third normal. Just read the, just go through the functional dependency. So here the key is actually the title and publisher ID, and the non-key attributes are the page count and price. Okay, title and publisher ID determines page count, and page count determines price. That is actually the problem here. The price is actually dependent on the dependence of price on title and publisher ID is actually transitive through page count. That means I can say that title you have the page count determining price, okay, and the title determines the page count. So page count determines price. So the dependence of price over title or that title publisher ID is actually transitive through page count. Both the price and page count depend on a key in second normal form. All right. So price and page count, the non-key attributes are dependent on second and fully functionally dependent on the title publisher ID, hence it is in second normal form. But transitive dependency is here, that is title publisher ID determines title and publisher ID put together determines price, or this dependency is actually transitive through page count. Because of the transitive dependency, the table is not in third normal form. Now here there are two more examples given where the tables are not in, or the table is not in third normal, or where you find a transitive dependency in the among the non-key attribute and the primary. Just go through the examples and convince yourself. One is on the studio and the other is on a building and the contract. Okay, it is actually self-explanatory. You can find that the first case, or can anyone explain why it is in the not in second normal form? Abhinijit,
Yes, sir.
tell why the first table, studio, city, temperature is not in third normal form.
Yes.
What is the reason?
It is not in third normal form, right?
Yeah. What is the reason?
There is transitive dependency.
Tell what exactly it is.
Sir, in
Yes.
2 and 3 are implying transitive dependency.
What is transitively dependent on what?
So transitive dependency is A to B, B to C, then A to C. That is the transitive dependency.
Yeah, I'm asking on this context, on this example.
Yes, a studio to studio, city temp. That is a transitive dependency.
Yeah, still you are not answering directly. Actually, the dependence of the temperature on studio is actually transitive through the studio city. All right. So
Yes.
temperature has actually nothing to do with the city. I mean, nothing to do with the studio. So even though it happens that the city temperature is dependent on the studio, it is actually dependent on the studio city. So city has a temperature, and city, every studio is in a city. So, and the city has a particular temperature. So the dependence of the temperature on the studio is actually transitive through the city. So studio determines city temperature is actually not correct, in the sense it is through the studio city. Studio determines studio city and the city determines the temperature. Because of that, you say that studio determines temperature. So the dependence of the temperature on the studio is actually transitive through the city. So it is not non-transitive, or it is not a direct dependency. It is transitive through the city, hence it is not in third normal. Similarly, can anyone explain why the second table is also not in third normal form? The same way, can you explain, give a satisfactory explanation? Fasil? Fasil?
Yes, sir.
Yeah, can you explain quickly in this example why it is not in third normal? Fasil?
Yes, sir.
Avani?
Here, building ID determines contractor, and contractor determines fee. Here, fee is transitively dependent on building ID.
Avneet Kaur, can you give a better explanation? Fasil has explained it. Can you add something more to that? Avneet Kaur is not present. Me too.
Yes, sir. So here, building ID is the primary key, and here fee is dependent on building ID through the contractor, so which is a transitive dependency. So it is not in third normal form.
Okay, that means when I say the building ID, I can correctly say who is the contractor, who is the fee. But the dependence of fee on the building ID is actually transitive through the contract. So contractor determines fee. That is actually the direct dependency. And building ID determines fee is actually a derived dependency which is transitive through contract. So it is again not in third normal form because of the transitive dependency. Now let us see how these are normalized into third normal. So here comes the steps. So this is important. You know that, but just recollect those things. For decomposing a relation into say 2NF relations into 3NF relations, these are the steps. Move all items involved in transitive dependencies into a new table. All right. Identify a primary key for each of those new entities or new tables. Place the primary key for the new table as a foreign key on the original table or original entity. So we have title, publisher ID, page count, and price, and found that publisher ID, page count determines price. So that can be one table, and you have title, publisher ID determining page count can be another table, which both are in third normal. Just cross check it with the previous one. Okay. Similarly, here we have studio, city temperature. We found that city determines city temperature, so that we separate into one table, and studio determines studio city. In that way, we divided this table or decomposed this table into two smaller tables: studio city, studios, and city temperature. And when you take a natural join of these two, you get a table where you have studio city, and city temperature. So here you have made you made the studio city a common attribute. So using which you will be able to, our studio city is here, and it is actually a foreign key. So when you take the join, you get the original table, all the tuples back. So similarly, building ID contractor fee, that is the actual table, but we found that building ID determines contractor, and contractor determines fee. And when we take a join of these two, you get the original table back. So the new two tables, new scheme or schema, these two tables are actually in third normal. All right. So contractor determines the fee, and building ID determines the contract. So these two tables, which are shown here on the right side, are actually in the third normal. Now, going further, BCNF, Boise code normal form, is actually an improvement over third normal form. It can remove more redundancy than in third normal form. And another key feature of BCNF is that it is defined independent of other normal. That means in third normal form, we say that the relation should be in 2NF, and then there should be non-transitive full functional dependency. In second normal form, you say that the relation should be in first normal form and then another condition. All right. So here it is defined independently. That is one difference. BCNF does not allow dependencies between attributes that belong to candidate keys. So that is actually the key difference here. BCNF does not allow dependencies between attributes that are part of candidate keys. BCNF is a refinement over the third normal in which it drops the restriction of non-key attributes from the third normal. Third normal form and BCNF are not the same if the following conditions are true. A table has two or more candidate keys, and at least two of the candidate keys are composed of more than one attribute, and the keys are not disjoint. That means the composite candidate keys share the same attribute. In such cases, the third normal form and BCNF are not the same. Okay, so these are very important, or there is a clear distinction between BCNF and PNF. So please read these points carefully and then we will discuss. Okay, so here the point is that third normal form is relaxing the condition of full non-transitive dependence on the primary key or attributes which are part of some key. If you have a candidate key and if the attribute is part of the candidate key, it can go for, or it is allowed that there can be transitive dependence, or there is there is transitive dependence for attributes which are actually part of the candidate. So the condition of non-transitive dependence is applicable only for non-key attributes. So if there is an attribute which is actually part of a candidate key, then it is exempted from the condition of non-transitive dependence. So that condition is not allowed, or that relaxation is not there in the BCNF case. So in the case of BCNF, the condition of full and non-transitive dependence is applicable for all attributes irrespective of whether it is part of a candidate key or not. So all the non-key attributes should be non-transitively and fully functionally dependent on the primary key. That is actually the condition of third normal. So third normal form is soft, or it relaxes the condition for attributes which are actually part of a candidate. So that relaxation is not there in the case of BCNF. And BCNF is found to be better than 3NF in the context where there are multiple candidate keys and those candidate keys are overlapping in nature. Okay, so in those cases where there are multiple candidate keys and when there is an overlapping among those candidate keys, BCNF is found to be better than PNF. On all other cases, BCNF and 3NF are going to be the same. Or if you apply BCNF condition, or if you apply 3NF condition, you would get the same result if there are no overlapping candidate keys. All right. So there comes the difference between BCNF, that is the Boise code normal form, and third normal. Any questions on this or any clarifications on this? The difference between BCNF and 3NF are very thin, or BCNF is an improvement over 3NF, but basically there is the difference is very narrow. So if you have any questions on the difference between BCNF and 3NF, where one is going, BCNF is going to be better, please ask now. Piyush Keswani, under what circumstances BCNF will be better than 3NF?
Sir, in the condition of if the keys are overlapping, then BCNF would be better.
Okay. So what is the weak point of 3NF when compared to redundancy? I mean, when compared to 3NF, the case of normalization. Praneet Kumar.
Sir, it's a transitive dependency, sir.
Transitive dependency is not allowed.
Yes.
What is the weak point of 3NF?
Sir, I think decomposition.
No. Celeste. Celeste. No response. Rahul. Rahul Moharana.
So the keys are disjoint in both the tables, in 3NF form.
Now, what
So
is the
reducing the probability of overlapping.
Okay. What is the weak point of 3NF?
So the non-key attribute is dependent. So there is common attribute between both the tables, which is in 3NF.
Okay, so the condition of non-transitive dependency is applicable only for non-key attributes. If there is an attribute which is actually part of a key, then that is exempted from the condition. So that is actually the weak point, or that is actually the problem with the third normal. If there is an attribute which is actually part of a key, then it can escape from the condition of full and non-transitive dependence on the primary. But in the case of BCNF, that condition is not there. So every attribute is required to fully functionally dependent on the primary. Or if you have a functional dependency of the form X determines Y, then X should become the key of the table. So that is actually the power, or that is actually the improvement in the case of BCNF. So the difference between BCNF and 3NF are very thin. So BCNF is found to be better in cases where you have multiple overlapping candidate keys. All right. And the weak point of 3NF is that it is soft, or it is not insisting the non-transitive dependence on the primary key for those attributes which are part of any of the candidates. All right. So when we are coming to BCNF, place the two candidate primary keys in separate tables. All right. Place each of the remaining data items in one of the resulting tables according to its dependency on the primary. So here the condition is that if there is a functional dependency of the form X determines Y, X should definitely be the key of the table. So here a table is given where you have city, street, and pin code or the zip code. So when you say the pin code, you understand the city. When you give the city, you understand the seat. You understand the street. All right. So here what happens is, if you take pin code or zip code determines the street and city determines the street, actually you are losing the functional dependency, transitive dependency that zip code determines the city. That is lost in this particular case. So actually zip code determines street. The first one, zip code determines the street, is actually a derived functional dependency, which is coming from these two. That means zip code determines the city and the city determines street. So hence zip code determines. So you should not decompose a table into subtables based on a transitive dependency. So zip code determines it is actually a transitive dependency, and if you decompose the table into two based on a transitive dependency, then you will lose some actual direct dependency. So here actually the zip code determines city is lost if you decompose the table like this. So the better decomposition is zip code street and zip code city. So where you take the direct dependency. Zip code determines city and zip code determines street. You decompose it using that, you get all the functional dependencies preserved. All right. So we will go further on this in the next class. We will see more about BCNF and about 4NF in the next class. Before that, if you have any questions, please ask. Are you having any questions?